I see a problem. Your model shows high bias and low variance. This means it's too simple and doesn't capture the data's patterns well. It's underfitting. Think of it like trying to fit a tiny square peg into a giant round hole. It just won't work. We need to make the model more complex. Let's find ways to improve your model. We'll consider different changes to see which ones will help. The alpha parameter controls regularization. Think of regularization as reins on your model. A higher alpha is like tightening the reins, making the model simpler and less prone to overfitting. But with high bias, you're already too simple. So, let's loosen the reins. Decreasing alpha makes the model more flexible. max_iter sets how many times the model learns from data. More iterations mean the model has more chances to learn the patterns, potentially reducing bias. It's like giving your model more time to practice. With enough practice, it'll get better. The loss function determines how the model measures errors. A different loss function might help it learn better. This one's a bit experimental, but it could make a real difference. We're trying a new approach. Increasing alpha makes the model even simpler, which will worsen the already high bias problem. This is like using a smaller peg for the giant hole. To improve the model, I'm thinking we'll focus on reducing bias by making it more flexible and giving it more time to learn from the data. I see a problem. Your model shows high bias and low variance. That means it's too simple. It's underfitting the data, missing important patterns. We need to make it more complex. Increasing alpha makes the model simpler by increasing regularization. This would worsen the existing high bias. It's the wrong approach. Decreasing alpha reduces regularization, allowing the model to become more complex. This directly addresses the high bias. Exactly what we need. More iterations, max_iter give the algorithm more chances to find better solution. It helps reduce bias if the model hasn't learned enough. The loss function guides how the model learns. Changing it can improve how well the model fits the data, potentially reducing bias. Let's try it. It's worth exploring. I'm looking for actions that will help the model learn more complex patterns and fit the data better, reducing the high bias. I'm tackling a problem where my SGDClassifier, stochastic gradient descent classifier, a machine learning model, isn't performing well. It shows high bias and low variance, meaning it's too simple and underfits the data. I need to find ways to improve it. My model's struggling because it's too simplistic. Think of it like trying to fit a straight line through a curvy cloud of data points. High bias means it's missing important details, while low variance means it's not overly sensitive to the specific training data. The core issue is underfitting. I have a few strategies to make the model more complex and capture the underlying patterns better without overfitting. Decreasing the regularization strength, increasing the number of training iterations, and experimenting with different loss functions. The ALPHA parameter controls regularization, which prevents overfitting by simplifying the model. I want to decrease ALPHA to make the model more flexible and less restrictive. Reducing alpha reduces the penalty for complexity, enabling the model to learn more intricate relationships within the data. The MAXITER parameter sets the number of training iterations. I'll increase MAXITER to give the model more opportunities to learn from the data. More iterations can help the model converge to a better solution and reduce bias. A loss function measures how well the model is doing. I'm going to experiment with changing the loss function. Perhaps trying a different one might improve how well the model fits the training data. It's worth a shot. We're troubleshooting SGDClassifier, stochastic gradient descent classifier, in Sklearn. It's a machine learning model used for classification tasks. The goal is to improve its performance. I've found the model has high bias and low variance. This means it's too simple and doesn't capture the data's patterns well enough. It's underfitting. Think of it like trying to fit a straight line through a curvy dataset. It's not going to capture all the nuances. To fix high bias, underfitting, I need to make the model more complex so that it learns more patterns from the data without overfitting. High variance. We'll adjust hyperparameters to achieve this sweet spot. Increasing alpha strengthens L2 regularization. This simplifies the model further, likely worsening the already high bias. It's not a good solution here. It'll make things worse. Decreasing alpha weakens regularization. This allows the model to become more complex, potentially reducing bias. This is a good approach for our high bias problem. Increasing MAXITER, maximum iterations, gives the algorithm more chances to learn from the data. This can potentially reduce bias by allowing the model to converge better to the optimal solution. Think of it like giving the model more time to study. Different loss functions, e.g., hinge versus log, optimize the model differently. Changing it might help the model fit the data better, and this could also reduce bias. This step is more exploratory. The success depends on our specific data. This means my model is too simple, it's underfitting the data. It needs more complexity to learn the patterns. Think of it like trying to fit a straight line through a curvy set of points. It won't capture the details. Increasing alpha increases regularization. This makes my model simpler. That's the opposite of what I need since I already have high bias, which is caused by too much simplicity. Decreasing alpha reduces regularization. This makes my model more flexible, allowing it to capture more complex patterns in my data. This directly addresses my high bias problem. It's a great solution. More iterations mean my model has more chances to learn from the data. My stochastic gradient descent, SGD, algorithm will hopefully converge to a better solution, reducing bias. Think of it like giving my model more time to practice. Different loss functions affect how my model learns. Sometimes, switching the loss function can help it fit the data better and reduce bias. It's like trying different teaching methods to see what works best for my student, the model. It's worth experimenting with. I see a problem. We're using a scikit-learn's SGDClassifier, stochastic gradient descent classifier, for a binary classification task. But the model's performance is bad. It has high bias and low variance, which means it's underfitting. We need to figure out how to improve it. Increasing alpha increases the regularization strength. This makes the model simpler, which might improve variance but worsen the already high bias. This is not what we want here. Decreasing alpha reduces the regularization. This makes the model more complex, allowing it to capture more intricate relationships in the data and potentially reduce bias. Which is exactly what we need. The _max_iter parameter controls how many times the algorithm iterates through the data. Increasing it gives the model more chances to learn from the data, potentially reducing bias if it didn't have enough time to learn initially. More iterations equals more learning. The loss function dictates how the model learns. Different functions can lead to better or worse fits to the data. Trying a different loss function could potentially reduce bias, but it's a more experimental approach. Let's try it if other options fail. I see a problem here. The model shows high bias and low variance. This tells me the model is too simple, it's underfitting the data. It's not capturing the important patterns. Think of it like trying to build a house with only a hammer. You're missing essential tools. We need to make it more complex. Let's figure out how to improve this model. We'll explore different actions to see which ones might help. The _alpha parameter controls how much we penalize complex models, regularization. Lowering alpha reduces this penalty, thus letting the model become more complex, potentially reducing the bias. Think of it as giving the model more freedom to learn. The model uses stochastic gradient descent, SGD, to learn. _max_iter sets the number of learning steps. Increasing it gives SGD more chances to find a better solution, potentially reducing bias. It's like giving the model more time to practice. The loss function dictates how the model learns from errors. Using a different one might help the model learn more effectively and fit the data better. It's like using a different instruction manual, might lead to better results.